Assalamu alaikum everyone. In the last class, I have explained about the variable separable method for finding the general solution or the particular solution of a differential equation, first order, first degree differential equation. So I have told you we are having three methods for finding the solution for first order, first degree differential equation. In that, first we have taken a variable separable method. Now the second one is homogeneous differential equations. Here homogeneous differential equation means by the name we can understood that here homo means same, homogeneous means uniformity, or in the differential equation which is having same degree, or we can say same power. Okay. So homogeneous means an equation which contains, in which all the terms are having same degree. So this equation is known as, first type of differential equation is known as homogeneous differential equation. Okay. Now consider a function f of x comma y equal to x square minus 2xy. Name this one as equation 1. Name this function f1. Here we are having x square, here we are having x and y. X, y both are in product, so their power can be added, then we will get 2. So here each term is having power or degree 2. So that means this one is homogeneous differential equation. Now again consider f2 as f2x comma y equal to 2x minus 3y. Here x and y both are having power 1. Now consider another function f3x comma y equal to cos of y by x. Both x, y and x are having power 1 and 1. So this one is also homogeneous differential equation. Now consider another function. This one is f1, f2, f3 and f1. f4 is f4x comma y is equal to sine of x plus cos of y. Okay. So we can see in the first function f1, x and xy both are having power 2. Here x is having power 1 and y is 1. This one is also homogeneous. This is y is having power 1, x is having power 1. This is also homogeneous. But here in this case, we can't say this is a homogeneous function. We are having another way to check whether this one is a homogeneous function or not. Consider in f1, replace x by lambda x and y by lambda y in f1. Then check what will happen. Okay. So f1 lambda x comma lambda y equal to lambda x whole square minus 2 lambda x into lambda y. Okay. So lambda square x square minus 2 lambda into lambda square x comma y. Taking lambda square common in both the term, then we will get x square minus 2xy, which is same as f1, the function f1. So we have to write lambda square into function f1 x comma y. If this condition satisfied, then we can say that the given function is homogeneous function. So similarly, we can check for f2. Here replace x by lambda x, here also y by lambda y. Then take lambda common, you will get same bracket 2x minus 3y in lambda into, we can write f2x comma y. So this one is also satisfied the condition, it is also satisfied the given condition. Now we will check for f4. Okay, I am writing here. For f4, replace x by lambda x and y by lambda y. See here. Then it will become sine of lambda x plus cos of lambda y. So we can't say this is same as lambda raised to n power f of f4 of x comma y. We can't say this one. We satisfy the function as, if we are replacing x by lambda x and y by lambda y, then we will not get this. If this condition will not satisfy, that means the given function of O is not a homogeneous differential equation. So what is homogeneous differential equation? Is an equation which is a function is said to be homogeneous differential function of degree n if a function f comma x a function f of x comma y is said to be homogeneous differential equation of degree n if f of x comma y is equal to lambda raised to the power n f of x comma y for any non-zero number lambda. Lambda is a non-zero number. So homogeneous is simply the differential equation in which each term is having same degree. So same degree, then we can say that the given function is homogeneous differential equation. So we are having some steps to solve such type of differential equation. Now let's see what are those steps, and according to that steps or by following that steps we can find the solution of given differential equation. We can check by the adding the power or by the power. If we can check the given function is homogeneous by checking their power. If they are having same power, we can say, or we are having another way by lambda, by replacing x and y by lambda x and lambda y respectively. Okay. Now let's see steps. We are having, let a function homogeneous of let a function homogeneous function it is. We are solving homogeneous. Let a homogeneous function f of x comma y. Okay. Now consider f of x comma y is equal to dy by dx. We are taking this function dy by dx as g of y by x. Name this one as equation 1. Okay. Name this one as equation 1. Now we are having y by x, taking this, substituting y by x is equal to v. We are taking, and how to substitute? We can take the given function is either it may be in the form of dy by dx or it can be in dx by dy. So how to take v? V is, if you are having here y by x, if you are having y by x, here you are having y by x, then you have to take y by x as v. If you are having dx by dy, then you have to take v as x by v, y equal to v. Okay. So now then it will become y is equal to v into x. Name this one as equation 2. Wait. Okay. Now differentiating with respect to x. Differentiating with respect to x, we get differentiation of y with respect to x dy by dx. Product rule, by using the product rule, into x differentiation is 1, so v plus v into first into differentiation of the second function. Differentiation of second function is here x differentiation is 1, v into 1. Now take second term x as it is now, and the differentiation of first term v dv by dx. Name this one as 3. So putting the value of dy by dx. We got dy by dx as v plus x into dy by dx. So putting dy by dx in value in equation 1. We get dy by dx replace dy by dx as v plus x dv by dx is equal to g of y by x. We had taken y by x as v, so g into g of v. Name this one as equation 4. Now what we have to do? Here we are having two terms x and y, v, and v is a variable term here. We can differentiate it. It is not a constant term, it is a variable term. So now we have to go for variable separable method. Okay, we have to separate v term and x term separately. We have to write. So we are having v plus x dv by dx is equal to g of v. So x dv by dx keep as it is, g of v minus v. I am taking this v here, it will become minus. Now we can take dv by g of v minus v and dx here. I am taking this term, this whole term here in the denominator and this dx in the denominator. Dx which is in the denominator, it goes up means it will become numerator, dx by x. Okay, we are using here variable separable. Using variable on variable separable. Right here, variable separable. We get. Okay. So now on integration, now we can integrate. After integration, we will get required result or required answer. On integration, integrating both the side, integration of 1 by g of v minus v dv is equal to integration of 1 by x dx plus c is the constant of integration. So we will get result, required result. We will get required solution of given function by, after integration we have to substitute the value of v. We have taken as y by x. After integration we have to take the value of, we have to substitute to replace v by y by x, then we get the, finally we will get the solution of our given function by replacing v by y by x. Here first step is the given question. Now the second step is we are taking y by x as v. Here we are having dy by dx is equal to g of y by x. Dy by dx is having, that's why we are taking v as y by x. If the question is given to you, dx by dv is equal to g of x by v. If x by y is given to you, then we have to take x by y as v. Okay. Now after this we have to differentiate the given, this y we will get dy by dx value. Substitute this dy by dx value in equation 1 or the given question, then we will get another equation by variable and which is in the form of v and x. Now we have to separate the variable v terms one side and another x term another side, then we will get this form. Name this one as equation 5 and this one as equation 6. After integration we will get the required result, and after the integration we have to substitute, replace v by v. We have taken as y by x, so we have to replace v by y by x, then we will get the required solution for given homogeneous differential equation. So these steps, by following these steps we can easily solve the problems. Okay, so let's solve some example based on this. homogeneous differential equation. We are using variable separable method also here. Okay. After differentiation of Vx, we have to use variable separable method. And after variable separable method, it is easily, we have to, after variable separable method, we have to go for integration. Then we will get the required answer. Now let's solve some example based on this. Write down example. Write down example. Solve the differential equation. Solve differential equation. An equation is given to you. dy by dx is equal to x minus y divided by x plus y. Okay, so we have to solve the given differential equation. First, we have to check whether it is a homogeneous differential equation or not. Write down solution. Given, right? Given differential equation dy by dx is equal to x minus y divided by x plus y. It is x. Name this one as equation 1. Here, x is having power 1, y is having power 1 in the numerator. Both are having same power. In the denominator also, both are having same powers. Okay, so we can say that the given function is a homogeneous differential equation. But we are having another way to check whether the given function is a homogeneous or not. So, first let a function, given function is, now replacing x by lambda x and y by lambda y respectively, we get write down f of lambda of x comma lambda y is equal to lambda x minus lambda y divided by lambda x plus lambda y. Okay, lambda is common in the numerator and the denominator, so we can take lambda of x minus y divided by x minus x plus y. After taking lambda from the numerator and after taking lambda common from both numerator and denominator, we will get x minus y divided by x plus y, which is in the given differential equation, or which is same as f of x comma y. So we can write lambda as it is f of x comma y. If you are taking x by lambda x and y by lambda y, we will get same as lambda of x comma y. So that means the given function is a homogeneous differential equation. Okay, you can write given function is homogeneous differential equation. Okay, now we have to follow the steps. First, we have to take y by x as b because we are having dy by dx. Okay, so let y by x is equal to v. This implies y is equal to v into x. Okay, now differentiation or differentiating this with respect to x, we will get dy by dx is equal to v into x. Differentiation is 1. We have to apply here product rule. So first term keep as it is. Differentiation of second is 1 here because differentiation is 1 plus x. Differentiation of v is dv by dx. Okay. Now, name this one as 2. We have to substitute dy by dx value in the given function. we got dy by dx as v plus x dy by dx, and whenever we are having y, we have to replace that y by v into x. Okay, here we are having, putting dy by dx value in equation 1, we get v plus x dv by dx is equal to x, and also we have to replace y by v into x minus vx divided by x plus vx. Okay, so here v plus x dv by dx is equal to, x is common, 1 minus v divided by x common 1 plus v. Okay, so this v, x and x get cancelled. What is remaining? V plus dv by dx, x divided by dx, 1 minus v, 1 plus v. Now I am taking this v here, v which is plus in the plus sign in LHS side, I am shifting this, then it will become minus. Okay, so x dv by dx is equal to 1 minus v divided by 1 plus v. This v, it will become here, then it is minus v. Now taking LCM, 1 plus v, 1 minus v into 1 plus v. For taking LCM means 1 plus v is LCM, then we have to multiply v into 1 plus v. Okay, see, 1 minus v. Now open this bracket, 1 plus v by minus v. Minus v into 1 is minus v square, minus plus v into v square divided by 1 plus v. So here 1 minus 2v minus v square divided by 1 plus v, x into dv by dx. Okay, so now we can go for variable separable method. Separating the variables, will get, here I am taking minus sign common, it will become, wait, if you are taking minus sign common, minus of v square plus 2v minus 1 divided by 1 plus v. Okay, so now we have to go for variable separable method. Separating the variable, right? Separating the variables. 1 plus v divided by cross multiplication you can take. Okay, this 1 plus v goes up, 1 plus v divided by, here it is plus v square 2v minus 1 is equal to minus vx by x. Okay, now we have to multiply. Here we are having v square, here we are having 2v. So multiplying both sides of this equation, multiplying by 2 on both the sides, then you will get 2 plus 2v divided by v square plus 2v minus 1 is equal to here 2 by x dx. On integrating both sides. Now we have to integrating both sides. Integration of 2 plus 2v divided by v square plus 2v minus 1 into dv, here dv, right, is equal to minus 2 common, 1 by constant keep. Okay, now we can see differentiation of integration is the reverse process of differentiation. Differentiation of v square is 2v, which is we are having the numerator, plus 2v differentiation is 2. One differentiation is 0 because it is constant. So the integration we will get log of v square plus 2v minus 1 is equal to minus 2 log of x plus log c is constant of integration. So we can write here log of 2 by x plus, we can write here minus 2. Here this power goes here, then it will become log of x raised to minus 2 plus log of c, log of c by x square it will become. Okay. So here we are having log of v square plus 2v minus 1 log of v square plus 2v minus 1. This log gets cancelled. What is remaining? V square plus 2v minus 1 is equal to c by x square. So replacing v by v we have taken as y by x. Substituting v value, v is equal to y by x. Okay. Replacing this v value here. So it is y square by x square. Okay. Wherever you are having v, we have to replace that v by y by x plus 2 y by x minus 1 is equal to c by x square. Okay. Now we can take x square as LCM here. LCM is x square. What is remaining? Y square. Plus here x's get cancelled. 1x is remaining. 2xy minus x square is equal to c of x square. C by x square. This x square get cancelled. So here we will get y square plus 2xy minus x square is equal to c, which is the required answer. Okay. So I think I go fast. Sorry. So firstly we have to write the given function. First we have to check whether the given function is a differential homogeneous differential equation or not. Then after checking if this satisfies the condition for homogeneous equation by replacing x by lambda x and y by lambda x, we have to put y by x as v and then y become v into x. Now differentiation we will get. We divide the dx value we got in terms of v and x. So we have to substitute that value of dy by dx in the given differential equation. Now by after substituting dy by dx value, we have to use the variable separable method. After separating the variables, we have to multiply. Here we are having v square plus 2v. So the differentiation of v is 2v and 2v differentiation is 2. That's why we are multiplying both sides by 2. After multiplying, we have to integrate. Integration of v square plus 2v minus 1 is log of v square plus 2v minus 1. How? If we differentiate, log x is 1 by x. So that's why log v square plus 2v minus 1 differentiation is 1 divided by v square plus 2v minus 1. Again, we have to differentiate v square plus 2v. Then you will get the required answer. Here we are having minus constant. 1 by x differentiation is x, log x. So we have to, by the log property, we can take this minus 2 as the power of x square, x. So it goes in the, here we are having x power minus 2, that's why it goes in the denominator. Here, this log and log get cancelled. What is remaining? V square plus 2v minus 1 is remaining. We have to replace v by y by x because we are taking v as y by x in the initial steps. So whenever we are having v, we have to replace that value by y by x. After replacing the v value by y by x, we have to take LCM. X square is LCM here. Y square, then after taking square LCM, y square plus 2 into xy minus x square is equal to cx square. So here in the denominator x square get cancelled. Y square plus 2x minus x square is equal to c is the required solution. Is the required solution. This is the required solution for given function or for given homogeneous differential equation. Okay. So with this I will stop. I will continue in the next class. The next class also I will take some more example based on the same homogeneous differential equation. Thank you. Jazakallah.